In this recording, we're going to take a look at uh, some topics we were not able to discuss last time. First, let's have a review of how to convert a range into a dynamic range. Second, we're going to take a look at the different finance functions. And third, some logistic functions. And fourthly, the assigned group work, the solution to the assigned group work. So let's first start with the dynamic range. When we create a range name for particular cells, okay, that named range is not dynamic. So let me give an example. In this case, we would like to give a name to this range of cells. Give it a name, revenues, the one here on the top of the column. So we learned last time that in order to create a named range, you just highlight this. Okay, and then you can either write the name here, can name it revenues, or you can press Control Shift F3 and Excel correctly guesses that the name is on the top row. So we click this OK. Now we have already an existing definition of revenues. So before we do this, let me illustrate to you how to delete this existing definition of revenues. So let me just cancel this. And I press Control F3, and then it will give us the names, the named ranges that we have already created. So I'm going to go here, revenues, click this, and then I'm going to delete this. Are you sure you want to delete? Yes. Okay. Okay, so now you can see that there's no more revenues, named range called revenues. I'm going to close this. So let me once again highlight this and then Control Shift F3 and create a new name, which is revenues. Okay. So now we have this named range. If we check the name box, you can find that revenues is here. If I click this, okay, so it highlights the values that that are part of the revenues uh, named range. Or you can take a look once again at our Control Shift F3. Sorry, Control F3 I meant. Control F3, and then we find here that revenues is here. Click this. Okay, so it refers to this uh, worksheet dynamic named range C3 to C16. C3 to C16. Okay, or you can. Uh, we learned also that you can press F3, and then it will give us a list of the named ranges that we have used. And revenues is here. You click this, okay. Then it highlights the where the named range revenues is located. Okay, the problem with this one is that this named range is static. So here we have created a formula which, okay, let me replace this. If I sum this up, sum, then F3, find revenues, okay. Now notice it highlights only the values uh, that represent the named range revenues. Control Enter. Okay, we have 5,270. Now, if I'm going to put a new data, for example, here, I'm going to put here 1,000. Notice that the sum did not change. The named range revenues still refer to this group of cells, okay, but it did not include 1,000. So if you want If you want to have a named range that's dynamic, which means that it adjusts when you keep on adding data, then we will have to make use of a formula for a dynamic named range. Now, the formula is makes use of offset and count. Count is very easy because count A simply counts the number of cells that are not blank. So for example, I list here 1, 2, 3, 4, and then if I count the number of cells that are not blank, if I highlight this, then it will give us an answer equal to 4 because it will count the cells that are not blank. Okay, count A. But if I put here a value, let's say 5, notice that it now included this the count of this number. Okay. So we're going to use the count A function in order to create a named range. Also, aside from the count A, is the function offset. So the function offset, let's take a look at what this does. Offset A, it returns a reference to a range that is given a number of rows and columns from a given reference. So we start with a given reference, and then it will give us, once again, a reference to a range. Okay, so this is a reference to a range, but you have to define what the uh, number of rows and columns are. So if we get this, so it starts first with reference, and then it asks us uh, how many rows do you want uh, to start the reference? Okay, so if we start from a particular point and then we count the number of rows from that specific reference, and also the number of specific columns. Okay, and then we're asked for the height and the width, but notice this is optional because this has brackets. Okay, so let me write that here. What we need is reference, and then rows, columns, and then height and width. So these are the parameters that we need to fill up for the offset. Let me write that, offset, open parentheses. There. Reference, rows, columns, height, and width. So we should be able to define what these parameters are. Okay. In our case, we would like to create an object called revenues, okay, that is dynamic. So how do we do that? So let me first delete this. Now I want that the object revenues be dynamic in the sense that if I keep on adding new data here, it will automatically include that data. Okay, so let's create now this dynamic range. Okay, so once again, we use Control F3. Okay, Control F3. Okay, so let's create a new one, and let's call it revenues. So the scope of this, which means is in the workbook, which means that anywhere you are in this workbook, anywhere you are in this, you can go to any other worksheet, then this revenues will refer to this dynamic range. Okay, so here let me create now new formula, it refers to, so we're saying that the object revenues refers to, okay, then let's type the formula is equal to offset. So we're going to make use of offset, comma. So recall that for offset, okay, let me just, move this here. Let's close this first. For our information, let's move this here so that we know what should be inside that formula offset. Okay, so let me just copy this and copying this to guide us. Let me just put it here. Okay. So once again, the file that was given you already contains this guide. So let's create once again a new dynamic range, Control F3. And then we create a new named range, dynamic named range. Let's call it revenues, or you may name it any way you want. Revenues. And let's now create the formula. So we're going to use offset. Okay, so the first parameter is reference. Where are we going to start for the named range? Here. Okay, so it's it's 232. Sorry, C3, the cell position. And then comma. How about the rows? So this you have to answer. Are we going to move down? If I put 1, it means that the reference will now move to the to row number 4. If I put 1 here, that means you're telling Excel that the reference should move 1 row below. Okay, and then if I put 1 again for the column, it means that the reference now will move 1 row down and then 1 row to the right. So that's what this means, 1 and 1. But we don't want the reference to move. We just want it to be here. So that's why we're putting here, how many rows will it move? None. It will still be here. And how many columns it will move to the right or to the left? None. The reference will still be here at C3. So that's what that meant. Okay, and then comma. Now we're asked for the height. Okay, the height means up to how many, what will be the range of our formula? Will it be up to row 21? Will it be up to row 100? So this will really depend on how we write our data. It's suggested that when you have a named range, then you allocate the whole column to it. But if you cannot do that because there are some values here, then you can just highlight here. For example, I'm going to highlight up to where will be the height of the named range. For example, I put there up to 100. Then my named range will be up to this one. Okay, so that's what we mean by the height there. But if I want the whole range, the whole column to be my named range, so that if I keep on adding to that values there, then it will still automatically be part of revenues. Then we can make use of the count function. Let me delete this. So we have here 0, 0, and we can make use of the count function. I'm typing here count A. Okay, count A, right? And then you can just highlight this there. So it's $C to $C. Okay, it means that it will occupy the whole column. Okay, so this option will now allow us to have a named range okay, up to this the whole column. Okay, so it has no limit in this case. But as I said, if you want a named range that has a limit, then you define up to what specific up to what specific row that named range will be. So in this case, I'll just use the whole column. That's why you have here count A. Okay. And then I close this one, this count A, and then comma. And the last one will be the width. So do we include, if the width is up to here, then we will have to include column D. Okay. So if I write 2, then that means this one and this one will be part of the named range. Column C and column D, because the width refers to the number of columns. But I'm just interested in this one column, so I'll just type here 1. Okay, and then close the formula. So that considers the reference, the rows, the columns, the height, and the width. So okay. Okay, so which means that, okay, let's redo this. Okay, there's already an existing revenues. Let me check. Okay, so we have to delete this first. If I delete this, delete. Okay, so there's no more revenues here. Close. All right, let's let me get the sum here again. Sorry. So what we did a while ago was to give this a name. Okay, this one again. Let me redo that quickly, and I'm going to give it a name, revenues. Enter. Okay, and then if I get the total, the sum of F3 revenues, it's the name that we used here. Okay. Okay, we included the named revenues. Okay, let's redo that. So let me highlight this. Control Shift F3. Control Shift F3. So we're creating names from using the top row. Okay. Replace existing definition of revenues. Yes. So revenues now is here. Okay, there. So this is the static revenues. If I get the sum of revenues there. So it only refers to this set of cells. And if I create a new data, include the new data here, 1000, it will not automatically add the new data. Okay. So as a let's just redo what we did a while ago. So I'm going to Control Shift F3. Sorry, Control F3 to create a new name. Control F3. Okay, new. And then let's just use another name because we already used revenues a while ago. So I'll use revenues 1. Revenues 1. And then let's define the formula for that. So offset Okay, where's our reference? Our reference is here. We start with this one. And you notice that it gives the name of the worksheet and then $C$3, this location. How many rows? Okay, still there. Okay, sorry. It will not move below or up. How about the columns? 0 columns, it means it will not move to the left or to the right. It will still remain there. And then comma, what will be the height of that name, of that object? I'm just going to click the whole column there. So you can see that it's $C up to $C, which refers to everything here. Okay. And if you're going to use this, make sure that this column is dedicated to just giving, just for the data for for revenues one. Otherwise, you will have to highlight up to where will be our dynamic name range. Then we have to close that count A. Okay, because we're using this formula count A, and we have to close that count A function, and then comma. The width will just be this column. We're not going to extend it to two widths, two columns. Then okay. All right, so we have now this object revenues one. Notice that, let me close this. Revenues one cannot be found here in the name box. A dynamic named range will not be found here in the name box. However, it can be found is equal to F3. It can be found here. There, revenues one. If I click that OK, then notice that revenues one referred to, notice this, it highlighted the whole column. So that way we now have a dynamic range. If I keep on adding to that, let's do that here. Once again, I'm going to create this total. Is equal to sum F3 revenues 1 here. Okay. So notice it highlighted everything there. Okay, it's still 5270, but if I add here 1000, you notice now that the formula for the static name range still remains at 5270, but the formula for the dynamic name range adjusts now. It adjusted to include the new data. Okay, so that's how you you use a dynamic name range. For the next set of functions, we go here. These are finance functions. So it involves looking at the computing for the present value and future values of a single cash flow, and then present value and future values of an annuity. And then we compute for the equivalent annuity value and the number of periods and interest rates. And fifth is we look at uneven cash flows. And then lastly, we have an amortization schedule. The formula to compute for the future value, as you know, future value is you'd like to compute the equivalent value of a single cash flow now. How much will be that amount X periods in the future? So let's have an example here. You have 150,000 now, and then the period is 10 years. And if the rate or interest rate is 12%, how much will be this amount after 10 years if the going rate is 12%? Now we can use the formula, this one. The future value is equal to the present value multiplied by 1 plus the rate raised to the period, which is 10 years. So let me write here the formula. So if we're going to compute for the future value, it's equal to the present value is 150, and then we multiply that by 1 plus the rate is 12%, this one, and then we raise it to the power to the number of periods. In Excel, the number of periods, the exponent is it's caret. It's in your keyboard, it's Shift 6, or in Mac, maybe Command 6. I'm not sure. But this is the caret symbol, which is generally above the number 6. Okay, and then T is 10 years there. So this is the formula, a mathematical formula to compute for the future value. Control Enter. So we have this 465,877.23. Okay, if I copy that formula text, so this is the formula for future value. Okay, or we can make use of Excel has a function called FV. So let me just rewrite this. So this is equal to FV. So that's the future value there, FV. And what are the parameters? Here we have rate, NPER, PMT, PV, type. So you have 5 parameters here. Okay, but 2 of them are in square brackets, which means they're optional. So first, Excel asks for the rate. This is the rate, comma. Then the NPER, number of years. So number of periods. NPER stands for number of periods, so it's 10. And then PMT. PMT stands for an annuity. Okay, an annuity is a stream of cash flows like this one. This is an annuity. So you have 60, 60, 60, 60, 60. You're receiving 60 for a number of periods. This is an annuity. In our case, this is not an annuity. This is just a single cash flow. So we're going to receive either 150 today, or we're going to deposit 150,000 today. It depends on the nature of the transaction. So PMT here is not relevant because this is not an annuity. So we can just type another comma, and Excel will read this to be 0. Or if you want, you can just type 0, okay, because this is not an annuity. Either or, we get the same answer. So let's just type a comma, okay, and notice that it now goes to PV. So what's the PV? The present value is 150, okay? And then the next parameter that's needed is type. So this type refers to annuity. So since this is not an annuity, you either type comma 0 or just ignore it. Okay, so there you go. If I press enter, then notice that it gives us a negative answer, negative future value. Now, this is important because Excel is very particular about the direction of the cash flow. What do we mean by direction of the cash flow? The present value here is plus, it's positive, which means that this is a cash inflow. We receive money. So what will be the future value? The future value will thus be a negative value, which means that we have to repay back. So this could represent a loan, a borrowing of 150,000. So cash in at a rate of 12% for after 10 years, we pay this amount. So that's why we have this negative. Now, if we're not interested really in identifying if this is a loan or an investment. If this was an investment, then your present value will be negative. So let me illustrate that. If this was a negative, which means that this is an outflow, you put out money for 150,000. So the future value will now be positive. So they should be opposite cash flows. Okay. So let me just undo that, Control Z, to revert back to the positive 150. And let's just suppose we're not really interested in looking at the nature of the transaction. We just want to find out what will be the equivalent value of 150,000 today after 10 years if the rate of return is 12%. I'm just going to put here a negative in front of FD. Control Enter. So it's 465,877.23, the same as the formula. Okay. Now for the reverse, we're given the future value. So I'm using here this value, 465,877, and we expect, of course, that the present value should be 150 because they're just equivalent computations. So for the future value, for the formula, we can make use of this. I mean for the present value. So if we're going to compute the present value, it's equal to whatever the future value is times 1 plus r. Okay. So this is now the discount rate, 1 plus r raised to the negative t. By the way, this is called for the future value. If you're computing for the future value, you are compounding the present value. So this is your compound factor. This is your discount factor. So this is equal to, using the formula, compute for the present value, we use the future value, multiply this by the factor, the discount factor 1 plus our rate of return is 12%, and then we raise it to the negative period. Okay, there you go. Control Enter, and true enough, we expect that the present value should be 150. These are equivalent computations. So if I make use of the PV function here, PV, okay, the rate is 12%, comma, N per number of periods is 10, comma, the PMT is an annuity. This is not an annuity, so I ignore that. So I now have future value. This is the future value. Okay, and then the type, once again, type has something to do with the annuity. And since this is not an annuity, we just ignore this. Okay, and then again, it will give us a negative answer because we're given that the future value is positive. Therefore, the present value should be negative because, as I said, Excel is very specific about the direction of the cash flow. So again, if I put here a negative sign, okay, to offset the negative answer, it will give us a positive answer now. How about the present and future values of an annuity? So as I mentioned a while ago, an annuity is a stream of cash flows. Let me just highlight this. There are two types of annuity. We first have the ordinary annuity. The ordinary annuity starts at the end of the period where the transaction was created. So for example, you bought let's say you bought a certain item and you will have to pay this amount. Okay. So you bought, let's say this is monthly. So you bought it in May. And if the payment will start in June, so this is May, this is June, July, etc. So this type of annuity is called ordinary annuity, where the payment starts at the end of the transaction period, at the end of this period, okay, which is the next month. That will be an ordinary annuity. On the other hand, an annuity due starts at the beginning of the transaction. Okay, so this one, you have to pay immediately 60, okay, or you get 60, whatever the nature of the transaction is. Okay, this is called annuity due. Now notice you have the same 60. So this is 10 instances of 60. This one is also 10 instances of 60. Okay, but this is ordinary and this is due. Now we could, of course, use the formula to get the present value of an annuity or the future value of an annuity, but it's a bit more complex. So let's just use the Excel formula. So let's have this example: 60,000 here, 8%, and then 10 payments. There are 10 payments here. So depending on whether it's an annuity ordinary and annuity due. Now, of course, if we take a look at if we examine the cash flow, the annuity ordinary, annuity due will have a higher present value. Okay, so if it has a higher present value, then it will have a higher future value. And why is this so? Because the cash flow starts immediately. For ordinary, the cash flow starts after one period. Okay, so computing for this, let's just erase this, delete this. Okay, for annuity ordinary, so we're looking at the present value. Present value, the rate is 8%, comma, N per is 10 periods, whether it's monthly or yearly. And then PMT, okay, what's our PMT? Our PMT is the annuity, that's 60,000. Okay, comma, notice there are two commas. There's no future value to this. You take a look at our cash flow, it's only the annuity of 60. If there was another amount here, say there's 1,000 here at the end, so aside from 60, you still have 1,000, then we have to include the 1,000 because it's in the future. Okay, but since there's no future value, we just ignore that comma, and then here the type. So 0 means it's at the end of the period, so that's the ordinary annuity, and 1 is at the beginning of the period. Okay, so if it's ordinary annuity, you can type 0. This is ordinary because it's at the end of the period. And if it's annuity due, okay, then it should be at the beginning of the period, then we type 1. So we either type 0 or you can also ignore that. It's okay also. We'll show that in a while. Okay, so this is, once again, we have a negative here because this is now treated as a loan. Okay, so you're going to get 60,000 in the next 10 months or years. Okay, so you will have to pay out first. So it's like a investment where you put 402,604.88 now, and then you get back 60,000 every period. So if we're not really interested we just want to get the equivalent amount, that's 402,604. So the equivalent of 60,000 for the next 10 periods, okay, at 8%, the equivalent of that now is 402,604.88. Okay. However, if it's annuity due, let me show this to you. So I said that you can, since this is 0, you can just ignore it. And this one is also 0, the future value, ignore it. Okay, so actually you can compute this using just the 3 parameters, rate, N per PMT. And as I mentioned a while ago, FV and type are bracketed, so it means they're optional. Okay, enter. So it's 402,604.88. Okay, if it's annuity due, then it's equal to, let's just put the negative here so that we have a positive answer. The rate is 8%, comma, N per is 10, comma, PMT is 60,000. Okay, all right. Now, no future value, ignore that or type 0. And then here we have to put the type 1. Okay, we have to put 1 because this is annuity due. The payment or the cash inflow or outflow, whatever the case may be, starts immediately. So you notice that, as I mentioned a while ago, the present value of your annuity due will be higher if it's, for annuity due. It's higher because the cash flow starts immediately. Okay, so we can also get the future value. So let's delete this. So the future value makes use of let me put negative already there. FV, future value. The rate is 8%, comma, N per is 10, comma, the annuity is 60,000, comma. Okay, no present values involved, comma. The type is end of the period. So let's just assume this is annuity ordinary. Okay. And then we get now 869,173. Okay. So this cash flow, 60,000, which begins at the end of the transaction period for 10 periods is equivalent to 869,193.75 at this point. Okay. So we can check. Since these are all equivalent values, 402,604.88 now is the same as 60,000 for 10 years at 8%, or it's equivalent to 869,193.75 single cash flow at the end of the 10-year period. So this 402 now 869 at the end of the 10 period, or 60, 60, 60 for the next 10 periods, they're all equivalent. Okay, so this time let's compute for the future value of this amount, this 402. So if I type FB here, rate at 8%, comma, period at 10. Okay, I ignore the PMT. I just compute the equivalent value if the present value is 402. Ignore the type. And we have control enter. Same thing. Same thing. Okay. So let's now go to computing for the annuity. So if we know that the present value is 402,604.88, what will be the equivalent? What will be the annuity if there are 10 periods and at 8%? Okay, so we should be getting, we know that we should be getting 60,000 because 402,604.88, if the transaction has 10 periods at 8%, it should equal to 60,000 as shown here. We computed for the 402,604.88 based on 60,000. So how do you compute for this? The function should be, I'm going to put here negative PMT. PMT stands for annuity. Okay, so that's the function that we're going to use. So rate, comma, N per is 10. We're given the present value, so let's use this. Okay. Future value, we're using the present value in order to compute the annuity. Of course, we can use the future value. So if you use the future value, then we should not put anything here in the present value. Ignore that and then type, you can just 0 or ignore it also. So this one, we expect a value of 60,000 there. So far what we have done is to compute for the future value, the present value of a single cash flow, and then here computed for both the present value and the future values of an annuity. Okay. Thirdly, we also computed for the annuity value itself. Okay. Of course, if we're going to use, let's say, the future value, let's see if we get the same thing. It's equal to negative PMT. I'm putting a negative there because our future value is positive, which means that we are going to get a negative value. The rate is also 8%, comma, period at 10, comma, the present value, we're not using the present value, we're using the future value, which is 869 there, comma, the type is 0, okay, and we get 60,000. Then let's go to computing for the number of periods and the interest rates. Let me delete this. we're given the present value at 402,604.88, which is the same amount that we got here, and then the 60,000 annuity. If we know the annual rate, then we can compute for the number of years. And we know that the answer is 10. But let's just prove that. So this is equal to N per. N per is a number of periods. The rate we know at 8%, comma. Okay, the PMT, the annuity is 60,000, comma. And then we're using the present value, which is this one, or you can use the future value, then comma. So with disregard the future value, so we're using the present value, comma, type is 0. If I run this function, notice that it gives us a wrong answer, -6. There cannot be a negative periods. Now what's wrong here is that we disregarded the very strict implementation of Excel as far as the direction of the cash flow. Here we use a positive present value and also a positive annual payment. That cannot be because it's not possible to have a transaction where you get 60,000 every period and you also get 402,604.88 at the beginning of the period. So this, we have to put a negative to one of this. Either put negative to the present value and then get positive for the annuity. Or we can put negative to the annuity and the equivalent present value will be positive. So as I said, Excel is very particular about the direction of the cash flow. So if I put here a negative, which means negative annuity, and then the present value is positive because they are two opposite cash flows. You get one inflow and then the other should be an outflow. So if we do this, then we now get the correct answer at 10 periods. Or I can put the annuity to be positive and the present value to be negative. There. So it's 10. Or we could have used also, if we use this, if we use on the other hand the future value, let's just see if we get the same answer. So N per, okay, the rate is at 8%, comma, PMT is 60,000, comma, present value, we're not going to use that. We're going to use the future value. But one of this, either the annuity or the future value should be negative. Okay, I place a negative there, comma. The type is begin at end of the period, 0, or just ignore. Then we also get 10. Okay. And lastly, so we have learned to compute for the present value, future value, annuity represented by the PMT, N per, the number of periods. One thing left, which is the rate. Okay. So let's, once again, let's use the present value and the annuity. And here the N per is 10, same thing. So we're going to use the rate function. N per, the number of periods is 10 months, 10 years, depending on the situation. PMT is 60,000, comma. PV, okay, we have to put a negative sign there. Negative 402, comma. No FV considered here. Type is 0. And then guess, just ignore the guess. Okay, so we get 8%. Okay, so you just follow the requirements of the formula. Now, this one calls for computing for the value of this transaction. Okay, so the question being asked here is, if we're going to invest 9 million now, and then we have this cash flow, 1 million for the first year, 2 million for the second year, etc., up to year 5 or the 5th period, 5 million. Then the question is this investment okay? So if you just sum this up, you're going to get positive 6 million. Now in finance, we don't do it that way because we cannot add the value at year 1, year 2, year 3, up to year 5. We cannot add these values because of the principle of the time value of money. 1 million after 1 year will not be the same as 1 million now. Okay, I'm sure given the option 5 million, we're going to get 5 million after 5 years or 5 million now. Of course, a rational investor would say that he would want to have 5 million now because what he can do is put that money in investment, and hopefully after 5 years, that 5 million has already ballooned or has grown to a bigger amount. So in order to answer that question, okay, if this investment is sound or not, then we make use of the concept called NPV, net present value. Net present value. Okay. So as the name suggests, present value. So what we can do is to convert each of this cash flow to its present value, and we know how to get that. We know how to get that. We can use the PV function. Okay, so for this one, the present value, of course, of 9 million is 9 million. Now, what's the present value of 1 million? The present value of 1 million, we can compute that, and also for year 2, year 3, year 4, year 5. Okay, so let's illustrate that. So this is PV. Our rate is given here. And I'm going to fix this. If you recall the F4, I press F4 so that this will be fixed. It will not move. It will, if ever I copy the formula, we're going to get still 11%, comma, what's N per? Our N per is 1. Okay, our N per is 1 here, comma. Then PMT we ignore because it's not an annuity. Okay, and then okay, sorry, I should have started here. Let's start here. Is equal to negative PV. Okay. PV. I'm going to put negative here. And the rate is this one. Can fix this one, comma. N per is, so it's variable. So here 0, it means that it's a present value. And then comma, PMT ignore. The future value is this amount. Okay, the type ignore because it's not an annuity. And then control enter. So as expected, the present value of 9 million is also 9 million. And if we copy this down, we can now see here, for example, this one, present value of, okay, the present value of 1 million, okay, at the rate of, this is the rate, 11%. This is the number of periods. It's 1 after 1 year. And this is the future value, it's 1 million. So the equivalent value of that is 900,900. Okay. So now these values are in the present values. Okay. So because they're now in the present values, then we can add them. If we sum them up, we get a positive value of 1319. 1319, which means this is called your NPV. That's your net present value. Notice that we just summed up all the present values, and these are all present values. Okay, so we did this the long way. There's a shorter way for that, and we make use of the NPV function. So let's type NPV. So in Excel, returns the net present value of an investment based on a discount rate and a series of future payments. Okay, so The rate is 11%, comma. Now, in Excel, NPV stands for, let me show that again. Returns the net present value of an investment based on a discount rate and a series of future payments. So future payments means uh, you should not put the current value. Okay, the value of the investment or the transaction at time zero. So what do we have to do with this one? Rate is 11%, and comma. The values that I should highlight is the one that's future. So starting with year 1 up to year 5. So this is the values, the future values. Okay. Now if I add this, okay, so value 1, value 2, value 3, okay, it will give us 10,319. So where is this 10,319? 10,319 is actually equal to sum. It's actually the present values of all the future cash flows, starting with this one. So that's 10,319. So it's the sum of the present values of all your future cash flows. These are your future cash flows, starting with one period after. Okay. Now, but for the net present value, this is not what we need. Okay, because this did not consider the initial investment of 9 million. So what do we have to do with this is we have to add also the initial investment. Now notice that I'm adding it because, okay, this is already in the negative. So generally, the first transaction is if it's an investment, then this should really be a negative. Okay, if I put negative here, then if I put negative and then highlight this, then that already becomes positive. Okay, so let's highlight that. Okay, Control Enter, that one. So this one, we got the same answer. Okay, so that's the net present value. And then here, there's another way to determine if your investment is financially viable. It's making use of the return of that investment, which is the IRR function. It returns the internal rate of return of a series of cash flows. Okay, so let's highlight this. This time, this is the series of cash flows, close parentheses, and we're getting this rate of return. So the rate of return of this project is 15.47. Now, what's our decision? How do we decide whether to push with the project or not? We decide by comparing the IRR, internal rate of return, with the required return. So the required return is 11%, and the project return is 15.47%. Then, therefore, we say that the project is feasible based on both the net present value and the internal rate of return. Okay. And lastly, we create an amortization schedule. So this one is very important, especially if you're going to invest in let's say, a capital asset, a house and lot, or a commod or a let's say a car or whatever. And usually when the value is quite high, then consumers are afforded the uh, you can buy the object, buy the item in installment. Okay, so this one is we're going to create an amortization schedule. Let's say you're going to buy an item, let's say it's a house, and you're going to course it through Pag-ibig. Usually, the market value, the value, appraised value, you cannot borrow everything. You have to have your own equity. So let's say that the down payment, you have to put up 20% of that. So the amount to be financed, amount that you can borrow is a certain fraction, a certain percentage of the market value. So let's suppose that the uh, down payment is 20%, the equity is 20%. Therefore, the loanable amount is the price multiplied by 1 minus 20%. So we have to deduct the equity. So what can be loaned is only 2.4. Let's assume that the transaction calls for a payment installment of 5 years. And let's say that this is the interest rate is 7.25. So usually when we have this transaction, it's based on a monthly payment. Okay, so that's 12 periods per year. So we can compute now the monthly interest, which is just the annual interest divided by the number of periods, which is 12. So this is the monthly interest, 0.6042. Okay, and then we can now compute for the annuity. This one, just like this one. So we can use the PMT function because that will allow us to, okay, so let's just do it here. So it's equal to PMT. This is the formula to compute for the annuity. Let me just increase the font size. PMT, right? The rate is, now, let's be careful because when the period is monthly, then all the data should be monthly. Okay, so the rate, we're not going to use the annual rate. We have to use the monthly rate because the payment is monthly. So the rate is this one. Okay. Now also the number of periods should not be the number of years. So it's 5 years, but the rate, the the amount, the annuity, okay, yeah, we're computing for that, should be all in the terms of the period. So NPER is not 5 years, but you have to compute it in terms of the month. So that's 5 times 12, then comma. The present value is this amount. That's that amount. Okay, that's what's being loaned. Okay, comma. A future value is none. Type is 0 because this is ordinary annuity. So the payment is at the end of the first period. Okay. Now let's put a negative here because we're going to get a negative answer there. Just put our annuity in positive terms. Control Enter. There. Okay, and let me just format this. It's in dollar. Let me just put this as a number. Okay, so that's the monthly amortization. That's what we're going to pay for the next 60 periods. Then how do we now create an amortization schedule? Okay, let me delete everything here. So that we're going to create our own. So we lay out here first the number of periods. So it's 5 years and it's monthly. So that's 5 times 12, that's 60. Okay, so let's start with the beginning. So at the beginning, we have the transaction. So we loaned 20% of the 3 million, so that's 2.4 million. So let's just copy this. So at the beginning of at the start of the transaction, we loaned 2.4 million. Okay, so that will be our principal balance. Okay, starting at the end of the period or at the beginning of month 1, then we will start paying now. Okay, so this is this one is constant. This is the monthly amount that we're going to pay. We can give this a name. Say month. Month. I'll just call it month amort. Okay, monthly amortization. Okay, so this one has a name, month amort. This one, that we can use that name range. Okay, and this one, let's also call it month int. Month int or monthly rate. Okay, so this one also has a name because this one are the specific values that we're going to make use of. Okay, so how much will be the interest? The interest will always be based on the remaining balance. So at the onset, at month one, the principal balance is 2.4 million. Okay, so we're going to have to multiply that with the monthly rate. So F3, this is where month rate, this one, okay, there. So that's how we compute for the interest. It's the principal balance multiplied by the monthly rate, which is 0.6042. Okay, so our interest for the first month will be 14,500. So the total amount that we paid, 47,086, 14,000 of that will go to interest, and only what remains will go to the principal. So the principal will be, let's make use of the a month amortization. Okay, this is the monthly amortization minus whatever we're going to pay for the interest. Okay, Control Enter, and as you can see, if we add this two, it should be 47,806. So a portion of this went to interest, and then a portion of this went to principal. So now our principal balance will be netted against the principal payment. So this is 2.4 minus this amount. Okay. So this is now our principal balance. Now for the next month, we can copy this because this formula is based on, okay, it's equal to the prior principal balance multiplied by the month rate. So if I copy this down here, okay, and check the formula, yeah, that's correct. It's a previous principal balance multiplied by the monthly rate. And this one, of course, if I copy this down, let's check the formula. Yeah, it's the monthly amortization minus whatever the interest payment was for the specific month. And then this one is simply the difference between the principal balance and the principal payment. So if I copy this down, okay, so it's the prior principal balance minus the principal. Okay, so these formulas, we can now highlight them and double click this one. It will now copy the formula down. And notice that at the end of the period, okay, this is the only amount that's left. It's 0, which means that we have completely paid the balance. The next functions that we're going to look at involve uh, filtering or advanced filter. So taking a look at this worksheet, given this data, so before we go to the advanced filter, let's have a see. Let's see first how we can create a model to forecast sales. So we're given sales here from January 2022 to December 2022. This is a one-year data. You have your sales here, and we're tasked to forecast the sales for the next 3 months. First thing to do is, best thing to do is first to plot our data. So I'm going to highlight the date and the sales, the 1-year data on sales, and then we insert, and we can use this under charts. There are several charts we can use, and let me use this scatter plot. So there are different scatter plots. Let's use a scatter plot without any marks on it. This one. So this gives us an idea of how our data, how sales has behaved over the past 1 year. We can see here that there seems to be a trend, in our sales. Sales seems to be going up. So if we're asked to determine or to forecast the sales for the next 3 months, we can use we call it a linear regression model. We can use that because there seems to be a linear trend as far as the data is concerned. Yes, in some points it was going down, but generally it was going up. The trend was going up. So using that, we can and in basic maybe math, in order to define a line, we have to determine the slope and the intercept of that line. So what we can do here is, given these data points, we can determine the slope. So we can use a function called slope in Excel. So this returns the slope of the linear regression line through the given data points. Okay, so our known y's, okay, our known y's are the sales value, this one, comma, our known x's, the one that we're going to put in the x-axis, either the date, or we can just use these index numbers, 1 up to 12. So 4377, so this is the slope, and it means that for every 1 unit increase in our x, there's a corresponding 4377 increase in our sales. In this context, for every 1 month increase for every 1 period increase in our date, which is 1 month, then there's a corresponding 4377 pesos increase in sales. And another metric that we need is the intercept, because the intercept will determine where it touches the y-axis. So same thing in Excel, you can use the intercept function, calculates the point at which a line will intersect the y-axis. So that's the intercept, and our known y's are our sales figure, comma, and our known x's are if we try the dates, yeah, let's see what happens. So it gives us an answer, negative 6387 630. So something seems to be wrong here. Okay. Now, because January 2022 pertains to a particular, it it has an equivalent number. So let me illustrate that. If I reformat this, okay, Control 1, and then go to number, okay. Currently, it's custom formatted to a date. But if I make this as a number, okay, then you can see that this represents a date in Excel is represented by a particular number. So the number is 44562. Okay, so actually this is okay. However, for the slope, what we used as for the x-axis is 1, 2, 3, 4. Okay, so just to be consistent, had we used this for our x-axis, then we would have gotten a different slope. Okay, and the intercept would be this. So just to make sure that I'm using the same x-axis. Okay, as I said, January 2022 is equivalent to 44562. Okay, so let me undo that, Control Z. Let me revert back to the original format. So for the intercept, I'm still going to use this. But I said you can use this for as long as for the slope you use this, and then for the intercept you also use this. because dates in Excel are represented by numbers. So let me change this and let me make my x-axis to be same thing, this one, 1 to 12. Okay, so I'm getting 19,024.50. So that means if I draw a line here, it will touch the x-axis here around 19,000. We can actually plot the this line, the linear regression line, by going here, clicking any point here. Okay, if I go here, right click, then we can choose this add trend line. Okay, and so this is the default linear, and we can click this one, display equation on chart. Okay, so you can see here, this one, okay, 143.87x, 143.87 times x, and then we have this intercept here. Okay, so let me redo this again. Let me repeat, add trend line. Okay, and then we click here the linear. We can also set it to forecast forward, how many steps forward and how many steps backward. And then here, display equation on chart, which I clicked a while ago. Okay, 143.87, which is the slope. Now notice that it's different from the slope that we computed. It gives us 143.87. We got 4377. And it's because, okay, if we compute here slope, known y's, comma, and known x's, this one, so let's use this as an x. Okay, you now can see that apparently what Excel used here is that it used the dates here as our y's. That's why you can see there's a difference between the slope for using the date as our x-axis. Okay, so this is our y-axis, this is our x-axis. But had we used this, then we would have generated this slope. Okay, so let me point this out this time. I'm going to plot this. Let me copy this and put it here in another section here, just to illustrate. I'm copying the data here, and then let me replace this with this one. So instead of the actual dates, I'm going to use an index. So this is 1 up to 12. And if we plot this, insert this one, you notice that the plot is identical, only that the index is different. Okay, the patterns are of course the same. And then if we add a trend line here, let's right click this and add trend line. Same linear, and then set the equation. You will notice that the equation will now be, will have a slope of 4377 there. Okay, this is the slope and this is the intercept. So this is uh, these are the values that we got here. 4377 and 19024.5, which makes use of 1, 2, 3, 4, 5, this one as our x-axis. Okay. Now, actually, it is the models are equivalent. The models are equivalent. So, for example, if I'm going to forecast the next month, there's a function called forecast in Excel. Okay, forecast that linear. And what are the parameters needed? Forecast that linear. So you have x, known y's, and known x's. Okay. So whether we use uh, since in this data, okay, we're using here the let's use the date here. So our x is this one, C17. This is our new x, okay, and our known y's are the sales here. So that's D5 up to D16, and then our known x's are the dates here. Okay, so the forecast will be 76033.27. So that will be the sales for January 2023. So we were able to forecast it for the next month, and then we can, if you take a look at this formula, C17 will be the new X, okay, and then the known Y's are this one. And if we fix this, we're going to fix the row $5 up to $16, which means that if we copy this down, if we copy this formula to the next cell here, then the rows will remain the same. It will still be $5 up to $16. So it will not change. This will still be the known Y's. And this will also still be the known X's. C5, this one, C5 up to C16. Okay, so Control Enter. And we can copy this formula down. Okay, so we're getting 80 and 84. And by how much did sales increase from February 2023 to January 2023? If we get the difference between this, then it will give us the 43 should be the slope for, okay, did I make a mistake here? So it's equal to this one minus this one. 4459.98 should be the same as this one. So, okay. $143.87, so which is the slope that we have here. Okay, and also this one, It's a difference between this one and this one. 4028.37. So we were able to forecast the sales for January 2023, February, and March. Okay, here I gave you here. Now this is changing because this is a formula. Notice this is a random number between 100 to 500. I just generated this just to show you how to create a spark line. And if I press F9, it's actually changing. So this is a dynamic value. So what's a spark line? A spark line allows us to provide in a cell the movement of our data. So how do we create this? Okay, we create spark lines by going to insert. Okay, and then where's our spark line here? Okay, let me. So we have here data. I just generated this randomly. I use the run between, generates a whole number between 100 and 500. I just wanted here to illustrate the creation of a spark line. So let me go to this cell, okay, and then insert, and then here you have the ribbon spark line. So you can have different types of spark line. You have line, column, win or lose. I'm going to choose line because this is most appropriate for time series. And the data range is this one. I'm going to create a spark line for this one. Okay. Choose where you want to create the spark line. I want it here. Yes, it's an S7 here. Okay. And then we can drop this down. Okay, here you have the different spark lines, and you can change this. Okay, you can edit this spark line, and here you can show the highest point there and also the lowest point there. So here it shows us the highest point and the lowest point. You can choose from different styles here. Okay, so for example, this one has a different high point and low point. The color I meant the color. So for example, this one, red for the lowest point and green for the highest point. Change that. There. So it's just a plot or a graph of a line graph of our data points. Okay, so that's what a spark line does. Okay, if we go here now to the advanced filter, so this is what we need to do. Given this data, you have the place where the item is sold. So it can be store or website or affiliate site, and then what product, and then the date it was sold, and then the sales value. So advanced filtering allows us to filter this data according to the according to some specifications that we want as regards the channel, the product, the date, or the sales value. So the first thing to do with advanced data is that this should be converted into a filtered data. Okay? So what's the shortcut for that? If you go anywhere here, anywhere in our table, in our data, and press Control Shift L, which is the shortcut. Okay, then you now can see that this now is filtered. Okay, you now have filter buttons here. Okay, then if we want, for example, a unique list of the channel, So if we want to know what are the different types of channels that this store has, we can do advanced filter. Okay, so okay, let me go here and then data and then advanced filter. And then it asks us, what do we need to filter? Let's copy the filter to another location. And what do we want to filter? It's not the whole. We're choosing the channel. This one. We're choosing this. Let me make sure that I highlighted the correct. So this one. Okay, and then I'm not choosing any criteria range. I just want to copy it to a particular cell. So let me copy it here, somewhere here. And then we want unique records only. Okay, so these are the different types. You have store, you have website, and affiliate site. Store, website, and affiliate site. Those are the unique uh, unique elements of a channel. Okay, then let's go here. We want to create a filter that will generate a list where the channel is stored and all products are present except Pants Blue. Okay, so what we want to filter is channel and product. For channel, we want only the store, and for product, we want all the products except Pants Blue. So how do we do that? You have to write here the name of the variable that we want filtered. So the choices are either channel, product, date, and sales value. So let's choose, we want channel, and you have to write there under channel, okay, you have to write store, because that's what we want filtered. And then for product, we want everything except Pants Blue. Okay, this is the result actually. This is the result. So how do we generate this? Let me copy this. Let me copy this here, just to illustrate this. So this is what we will be using for the filter. So once again, we go to data, advanced filter. Okay. So our list range is, we can actually choose our whole table. And our criteria range is this one. This is our criteria range. Okay. And we'd like to copy it to another location. So let's copy it here. Where did I put it? Let me copy it here. So what will happen is that Excel will now filter the channel and the product to contain only store, and also to contain all items except. So the less than and greater than here, less than and greater than Pants Blue means you include everything except this item. And if I click this, okay, so there we go. So this is our channel. You have only the stores, and the product include everything except pants blue. So you don't have pants blue. So it will generate also the other corresponding values in the date and the sales value. Okay, so this is how you do advanced filtering. Okay, so that's the first question. Now for the second question, store also, for the channel you have stores and all products with pants. Okay, so you have here pants blue, pants black. So if you want all the pants, whether it's blue or black, okay, and also shirt white. So there are shirt whites here in the product. Then how do we do such filter? So we have to write this for the channel. Notice that you can, it's not necessarily case sensitive. The channel here is capitalized, but here I'm not capitalizing channel. This will be okay. Now for the channel, you have, and the product, you have store and everything with pants. So when you say everything with pants, you can use asterisk and then pants and then asterisk. This means that it can have any text before pants, or it can have any text after pants. Okay, and then shirt white, you have to include again the parameter for channel. Here it's store again, and then shirt white. If you don't put this one, then you'll have the wrong answer. Okay, so let's copy this. The answer is here below. Okay, and you notice that, so we're just replicating this. I'm going to copy it here, probably. Okay, and then you go to data once again and advanced. And the list range, okay, is okay. And then what's our criteria? Our criteria is this one. The channel and the product. Channel is store and then all with pants. And also channel is store and then shirt white. So we highlight this and then we copy it to another location. Copy to, let's copy it here. Okay. And then we click OK. Then we have exactly the same answer. Okay. Now, shirt white. This is different. Okay, this was the one a while ago. All right, this is the same as the one above. Okay, third, we have store sales less greater than 300. So the technique here is to identify. So this is very easy. You have here store sales greater than 300. So there's only one variable that we're filtering, sales value. Sales value is the last column here. So sales value, and it should be greater than 300. And same thing, same process as a while ago, advanced filter, and then we highlight this, and then copy to this location. Okay, and here you can see that only those with sales value greater than 300 are included. So for the fourth question, you have store and all products with pants. Okay, you have store, all product with pants or shirt white and with sales greater than 300. So it combines the first three. So how do we do this? Okay, same thing. So we have channel, store. For the product, it's anything with pants. And the sales value should also be greater than 300. And the next one, store again, shirt white. And then notice that all the parameters should be complete. This will not work if it does not contain the greater than 300. This should be greater than 300. So if once again filter this, okay, so let me just use this. So you have advanced, List range, same thing. And then criteria range is, let's use this one. Let's use this one. And then let's copy it to another location. I'll just copy it here below. Here. Okay. And then okay. So you now have this result where your channel are all stores, your product are those with pants and also shirt white, and then the sales are greater than 300. Okay. And lastly, you have here store channels are all stores, and then all products with pants, shirt white, sales between 200 and 400. Okay, so this is what we exactly want. So you have channel, pants, channel is store and pants, channel is store and shirt white, and then we have two conditions for sales value. It should be between 200 and 400. So we put here sales value should be greater than 200, sales value should be less than 400. So this will now filter it in such a way that these two conditions have to be met. Sales greater than 200 and sales less than 400. Okay, so once again, if we do advanced, this is what I'm going to filter. Advanced. Okay, and then I'm going to copy it in a new location. The list range is this one. Okay, list range. The criteria is, the criteria is this one. Okay, and I'm going to copy it. Let me copy it here, here below here. Okay, and okay. All right, so uh, this is the correct one because it should be greater than 200 and less than 400. Let me redo this. I think I did something wrong here. So once again, advanced filter. List range is this one. Then our criteria is, make sure I highlighted the correct parameters. The criteria is this one, right? This one is the criteria. Okay. And then we're going to copy it to let's just copy it here, beside. Okay. Let's review. This one is criteria range. Let me just make sure it's this one. Okay. All right. Then AQ41 is here. Okay, so you can see here that we have the same answer. A while ago, I think I highlighted the wrong conditions. So everything here is store, everything here is pants or shirt white, and then everything here has values between between 200 and 400. Okay, so that takes care of the advanced filtering. Now for the last one, the group work, we were supposed to answer these questions. Okay, so let me just illustrate some of them and leave the others for your, this worksheet was already given to you. So this was supposed to be an exercise. I'll just illustrate some of them and then I will leave the others for you to explore. But the formulas are already given here. So I'm sure that you'll be able to follow along. Okay, so for this one, you're given this data. So you have the month, the application, how many downloads, how many were uninstalled, how many gave it a 5-star rating, a 1-star rating, and what was the total rating. So maybe they had some points here. Okay. So if you notice, this one is already a table. If we click anywhere here, table. So here, table apps 2. The name of this table is table apps 2. Okay, so let's recall that. Okay, so first we're asked what were the total downloads that begin with C. Okay, so this refers to the apps. Okay, for whatever reason, we'd like to know how many downloads were there for all applications that start with the letter C. Okay, so the condition is that it has to start with the letter C. Okay, and then how many downloads do we have here? Now let's take a look at the formula so that I will not have to repeat typing this. So if we're adding, we know that it should be sum ifs, and then from what we have done, we identify the table. So the table is table apps 2. Okay, and then we have to identify which specific column or variable in table apps 2. So let me just delete this. Okay, to illustrate that point. So I'm going to type TBL. Okay, and then you notice that there are many other tables here. And then we're using table apps 2, and then I'm going to press tab. Okay, so what are we? Sum range. Okay, what are we going to add? So let's put the square brackets here, and then it will give us now what are the variables available there. So what we're going to add is the downloads. Okay, so I highlight downloads and then tab, and then close this. So that's the sum range. That's where we're going to. Where we're going to add. And then what's the condition here? Criteria range 1. Where will be the condition be? So it should be in the app. Okay, it should be in the app because the condition is that it should begin with letter C. So that's where we get that. Okay, app. And then lastly, what's the criteria? The criteria is that you have L5, which is C, and you have asterisk here. Now this means that this becomes C and then asterisk. The asterisk here indicate that anything that follows C, any letter, okay, include that. So if we try to look at the apps here, so this will be included. Crushed by Candies, Chocolate Crossing, all that start with C will be included because that's the condition. Table apps 2, the table itself, and then look at the app column, and then the condition is L5 and quotes asterisk. So this will concatenate letter C and the asterisk. Okay, so it will now count 9536. How many instances, how many downloads were there for those with that begin with letter C? Now another way to do it, I place it here, is that you can put in quotes C and then asterisk. Okay, so this is also acceptable. Right, then total downloads for C apps between the specified dates. So you have a specified date 8/1/2021 and 11/30/2021. So this will also be used for the condition. So we have here again sum ifs. Okay, so what will be the sum range? We're going to add all that's in the download section. Okay, and then we identify the criteria. What's the criteria? Okay, here, criteria is, again, from the app variable L5 and asterisk, or it can be quotes, then C, and then asterisk. One good thing here is that we can change this. If we change L5, then automatically the formula this one will be changed. Okay, so it's not really advisable to put an absolute in a particular formula where you can use a relative, let's say pointing it to a cell instead of just typing the value. Okay, because the advantage of that is in case we want to have another output where the input is different, for example, I can put here D, then this will still work, this one, because it's linked to this particular cell. Okay, and then the conditions, it should be greater than or equal to L10, greater than August 1. And once again, another condition. Okay, here we have okay, if you notice, it's greater than or equal to and L10. This one, it's less than or equal to and L11. So you're concatenating it, and take a look at how the function is written. Greater than and equal to. Notice it's in quotes, because if it's not in quotes, it will not be recognized. Okay, less than or equal to and the reference cell. Okay, so that's how we can sum ifs all those values that start on 8/1/2021 and still start with the letter C. So you have here several conditions. Okay, and the total is 53,643, 640. Okay, so for this one, it's uninstalls. It's merely measuring another variable here, uninstall. So this is what we're going to use. December 2021 also. So two conditions. This one. Again, we're using the table apps too. And what are we going to add? The uninstalls. A while ago, we added the downloads. And then what's the condition? Okay, the criteria range is, we look at the month section, and then it should be case 17, that's December 2021. Okay, so here, that's a condition, or the criteria range 1, and then the criteria is those that have dates December 2021. Okay, so what's important here is the using of tables and naming of the tables and being able to access immediately what are the variables inside the table. Okay. All right. So here, 5-star rating. So we're tasked to determine how many 5-star ratings and how many total ratings for Sugar Rush and the percentage of 5-star ratings. So this is just measuring. Okay, we sum ifs, table apps too, and then what we're going to sum is from 5-star ratings, which is this one. Okay, and then the criteria is L21 is here, Sugar Rush. There. So look for Sugar Rush under this one. Okay. Look up here. Okay, L21. Look at the app Sugar Rush. Okay, and those with the 5-star ratings. Okay, for Sugar Rush we add. So we're getting 587. And then, so we have to compute for the total ratings for Sugar Rush. Okay, so here we're adding the total ratings, and then this is also Sugar Rush. L21, which is this one. So we have for Sugar Rush, the total ratings is 5353, and the total 5-star ratings is 587. So we can easily compute for the percentage of high 5-star ratings. Okay, for this one, we're just looking for the month with the highest uninstall. So we compare month by month. Okay. So how many uninstalls were there? So same thing. The sum range is uninstalls, and then the criteria range one is the month, this one, and then K30, June 21. So we're just going to copy this down so that it will compute what were the uninstalls for June 21 up to December 21. And the same thing, we compute for how many downloads were there. Okay, so we're adding the downloads and then getting the value of how many downloads were there in the month of June 21. Okay, so there were 34,801 downloads, 691 of which were uninstalled later on. So the uninstall ratio is simply the quotient of uninstalls, okay, divided by downloads. Okay, here I just inserted. So what was the maximum here? So I think I missed K36. Okay. What was the maximum here? 199.38. So this one. Okay. And then as I mentioned a while before, we can make use of the X lookup. If you have Excel 365, then you can make use of this X lookup. What are the parameters here? What's the lookup value? This one, 19938. So where are we going to look for that? Lookup array is, we're going to look for it at this one. Okay. And then lastly, okay, what's the return array? Return array is still this one. Okay, find. So N and then, sorry, K. I'm sorry. Okay, return array is this one. Okay. So find 19938 and this one, and then return whatever month that is. Okay, so this will now give us which month has the value of 19938, and it's July. Okay, so July had the highest uninstallment rate. All right, for average is just the same. We're just going to get the average. Instead of using sum if, we just use the average ifs. So it's exactly the same. So average download for June up to September. We're using the sum range as the downloads. We're going to average that. And then the parameter will be based on month, specifically this one. And we copy this formula down and we get the average downloads. Okay, question number 7. Okay, we're asked for the downloads. Okay, so which which had the most downloads? Okay, we're going to use max. Maximum of, from the table, you get the maximum of the downloads. Okay, and it's 10028. Now for this one, okay, downloads. Okay, notice now that I'm using here the function large. Then large, table apps 2, download, and then what's K54 here? K54 is 2, which means that we're looking for the second largest. Okay, second largest. If I used 1, okay, if I used 1, so let me put 1 here. Okay, then it will give us the maximum because it's 1. If I want the second largest, then I make use of the large function, large, and then from where? K54, that's number 2, which means that this is the second largest. And lastly, same thing here, but this time K55, this is the third largest. Okay, so the largest is 10028, 9195 is the second. And if we ask which of the apps here, which of the apps had the biggest download? And again, the best way to answer that is using XLOOKUP. Okay, so what are we looking up? We're looking up L53 is this one. We're looking up this value. From where? From the downloads here. So look for 1008 from the downloads and then give me the name from the app. Okay, so this is telling us, give us the name of the app pertaining to this value under downloads. And this is Chocolate Crossing. So the second one, same thing, same formula, is where is my Cocoa, and then Crushed by Candies. And then you can also find the month of the highest. So it's also, again, XLOOKUP. Okay, so plenty of things we can do with XLOOKUP. Okay, so here, we're asked for the most one-star rating. So our most one-star rating is this one. Okay, which has the most one-star rating? It's quite similar to the previous one that we used. Okay, and of course, we know that we have to use max ifs. So this is a maximum conditional function. So where do you find the max range? From the 1 star. Okay, and then what will be the criteria? The month. Okay, and what month? This one, L60. So we're looking for the most star rating, okay, for the month of October 2021. And you can see here that for the 1-star rating here, for October 21, okay, the maximum is 47. And also for December 21, also max ifs. Okay. Of course, if we want for the whole list, then we don't add the filter for October for the month. All right. So if we want, okay. So which one is this? Which application had the most 1-star rating? So we once again use the XLOOKUP. Okay, we're asking XLOOKUP to look for this. Where is he going to look for this? In table apps 2 under 1-star rating, and then give to me what is the name, the app name of this 1-star rating with 47. Okay, and it's where is my Cocoa? Okay, but is it and then for this one, same thing, 55. And then we're getting it from total ratings. Okay, and return the downloads. Now, we have here an NA value. Okay. Why do we have an NA value here? Okay, let's compare this with this one, with the right one. So XLOOKUP, M61, this one. Table apps 2, 1-star rating. Okay, we're looking for the value with the rating, the application with the 55 1-star rating. All right. So this one, we're able to get the formula text. get the name of the app. Okay. All right. For the next one, most downloads. Okay. Again, max ifs, just like the one above. Okay, and then we can determine what month was this. Again, it's just a matter of filtering. Okay. Filtering and then making use of the advanced functions like max ifs, average ifs, and then looking for that because here we first determine uh, this one. As far as Crash by Candice is concerned, how many downloads did it have? Okay. How many what was the maximum download it had? This one. Okay. So once we have this figure, we can now make use of the XLOOKUP. So we're saying, what is the lookup value? This one, 8586. Where are we going to look for that? We're going to look for that under downloads because this is part of downloads. And then what will be returned? What will be returned is the month. Okay. So the maximum for Crash by Candice, the app is 8586, and it happened on July of 2021. And so we have also the same for the others. For example, for Temple Bun, okay, we got first the maximum, and after getting the maximum, we determined on what month did it occur. So this occurred on September 2021. Okay, so thank you so much. That wraps up our discussion.